All right. We're going to pick back up with another example. On this one, example number 1, we're going to do tellurium, Te. So we need to go on to the periodic table of elements. Again, this is a very easy table to use right here. So here's tellurium 52. So we'll start off by writing tellurium 52. So we would write tellurium 52 right there, and then we need to go to the row above tellurium and find the noble gas on the end of that row. If I get lost, I can follow the numbers backwards till I hit a noble gas. A lot of people like to do it that way. So there's tellurium, and we can go straight left, just keep going down, counting the numbers backwards, 51, 50, 49, 48, 47, 46, 45, 44, 43, 43, 44, and we end up at this row 37. So we end up at all the row 37. And now I continue to go backwards. Before 37, I would have 36. And 36 would take me to krypton, the nearest previous noble gas. The other way to do it is just jump up a row and go down to the right. So tellurium 52 is there. In this row, it's in the 5th row. I would go back to the 4th row. See, it's in the 5th row, so I go back to the 4th row. And on the 4th row on the end, we have krypton 36. So I come back over here and I write krypton 36, and I put it in brackets usually to show that I'm replacing the inside of tellurium, the kernel of tellurium, with 36. Here's really what we're replacing. If we went to square one and worked our way to tellurium's row, we would fill the 1s, the 2s, the 2p, the 3s, the 3p, the 4s, the 3d, and the 4p. I would have to fill all that before I got to the row with tellurium on it. Tellurium's row would be the 5s2, 4d10, 5p4, as we can see right here. Here's tellurium. It's the 5th one over in the 5p. So all that stuff on the inside is called the kernel, and we replaced it. The business end of tellurium is the stuff that's on the 5th row. So I'm at krypton 36. That's what I replaced the inside kernel with. And now I'm just going to work my way from 36, krypton 36, up to tellurium 52. So after 36, 37 and 38 are right here, rubidium and strontium. That's the 5s. There's 2 elements there, so I would write 5s2. 5s2. After those 2 elements, I come to 39 through 48. That's 10 elements in the 4D. That is the 4D part of the table right there. It's written right here. That's why this is a really easy table to use for this. I would write 4D10. 4D10. And now I'm in the sublevel, the P sublevel, the 5P, where I find tellurium, and it's the 4th one over, so I would write 5P4. Now I total these to make sure I didn't leave anything out. 36, 2, 10, and 14. 36 and 2 is 38, and 10 is 48, and 4 is 52. So everything looks good. It's S2D10P4. I look here as a double check. Yep, right above tellurium. I go up, I see S2D10P4. How many valence electrons does tellurium have? Those are the electrons that are in the S2 and the P4. 2 and 4 is Roman 6. I know I've got tellurium's electron configuration, or the shortened version electron configuration, which we call noble gas notation, or compressed or condensed electron configurations. The next one, we would certainly be glad that we were going to be doing a noble gas notation, because we're supposed to do californium 98. Californium 98 is way down here in the 5F. It is the 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count that right? It is 1, 2, 3, 4, 5, 6, 7, 8, 9th one over in the 5F. When we're done, it should be an S2F10. You see the S2F10 underneath there. So there's californium. I would have to start all the way up at square one and work my way all the way through the table. To get the californium, if I was doing it the long way, I would have to write 1s2, 2s2. Then I would proceed over to here, 2p6. Then I would be at the 3s2, which would be right here. And then the 3p6, which is right over here, 3p6. Then I would bounce down into the 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. Then I would be at 6s2. After the 6s2, if you remember, we would follow the numbers down here, and we would write 4f14, and then we would pop back up into the 5d10, 6p2, 7s2, and then finally I would be where californium is, right here. But we can shorten all that using the nearest previous noble gas, where I can just back up the bus and find out who is in the row above it. So I would go 98, 97, 96, 95, 94, 93, 92, 91, 90, 89, 88, 87, and now I'm at my previous nearest noble gas, radon 86. So I would come right over here. This is what I just said, the 1s2, that was the stuff I kept talking about when we were looking at the table. I can replace all that with radon 86. That is the noble gas on the row above it, and I found that noble gas by just backing the numbers up till I got to the noble gas. So I would write radon 86 and put it in brackets. So I'm right here, radon 86. After number 86 comes number 87 and 88. I'm making that a little bit bigger so you can see if I would stop scrolling all over the place. It's a little hard to scroll on this thing. So we are at 86, I think. Yep, there's 86. After 86 is 87 and 88. Francium and radium. And they are in the 7s. And there's two of them. So what do? I write 7s2 right there. Now, they tell us that californium has no electrons in the 6d, which makes it a little bit easier because I can just count how far over californium is from the 7s2. So there's the 7s2. After number 88, I come to 89, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Californium is the 10th one over, so I would write 5F10. I would write 5F10. Now I'm going to check. 86 and 2 is 88, and 10 is 98. Everything adds up, and I have a 7s2, 5f14. It's an s2, I'm sorry, 7s2, 5f10, 5f10, and it's an s2f10. So I'm going to look underneath right here, californium, s2f10. I know I've done the correct nearest noble gas notation. In our next video, we're going to pick up with the even shorter way of representing where electrons are. They're called Lewis dot diagrams.